confirm you can hear me?
Yeah, all good.
Perfect. Okay, very good. Okay, so we can move this. Great. Okay, so good afternoon, everyone. So look, firstly this afternoon, I'm going to tell you a little bit about the company that I work for. So that's the Irish Cattle Breeding Federation. I'm going to give you a general guide into how some of our genetic indexes are derived, and finally then just introduce you into some of those Irish beef genetic indexes. So I work for the Irish Cattle Breeding Federation. So and it's typically referred to as ICBF kind of by most people, I suppose, within the industry. So it's the body responsible for providing cattle breeding services to the Irish agri industry. So we're a non-profit organisation. We're established, I suppose, over 20 years ago now at this stage as a co-op of 30 cattle breeding organisations at the time. We've a staff of in and around 70 people, and we service over 100,000 herds within Ireland. We have an operating budget of about 7 million, half of which comes from industry growth, and the other half, I suppose, comes from services such as the Herd Plus service, which would be more of an extension service which we provide. So we have several services that we provide to the agri industry. So the first of which is we maintain and grow the national database, which is really unique in a global perspective. I'll tell you a bit more about that in a second. And we also provide independent genetic evaluations to the industry. So they're updated every 2 months, and they contain data on national commercial animals for more than 30 different traits. And because I suppose that they are generated independently, and that means I suppose that there's a lot of trust, I suppose, within the industry on our genetic evaluations. So through these services, I suppose we help farmers to make more informed and sustainable breeding decisions going forward. So I mentioned the national database, which we maintain and we grow. So what it is it's I suppose it's a number of big machines that contains data points on over 100 million data points on at least 30 million animals. So that's a really big number, and the reason for that is because I suppose it contains data from an array of sources. So this is just a snapshot, I suppose, of where some of the data comes from. So would be data, I suppose, coming from the farmer, the Irish Department of Agriculture, vets, EI organisations, herd books, auction houses, and marts. So data flows into the ICBF database from these sources, and information also goes back out as well. And I suppose this helps to reduce the necessity for duplication of records. And all of that information would feed into the relevant national genetic evaluations. So just an example of some of the data points that feed into the evaluation. So I've just highlighted here. So about 2.4 million birth records would come in per year, 1 million AI serves per year, 7.7 million herd farm-to-farm movements per year, and 2.2 million slaughter records per year. So there's probably at least one record on every single animal born in Ireland somewhere within the ICBF database. So just to take you through just an example animal, so of a beef cow, what data we have on that animal potentially and where it comes from. So the first event would be the birth of the animal. The information that would come into the ICBF database would be the likes of parentage recorded, so the sire, the dam, level of dystocia, gestation length, whether the calf was born alive or dead, and that information then would come from the Department of Agriculture through our farm software technologies, or through animal events again, which is maintained by the Department of Agriculture. There could be information on weaning weight or on price that the animal was sold for at the auction house. So that would come either directly from the marts, or it could also come from farm information itself. If the animal calves down, again, that information would feed into the ICBF database, allowing us to give the animal indicators of fertility. So for example, at what age did the animal calf? Did she have a high level of dystocia? Did her calf die, etc. Live weights again on the animal. So as a cow or throughout her life, could come in from the farmer, a weight recording provider, or from the marts. Milk score information is another piece of information that is recorded through different schemes by individual farmers, which also comes into the database. Other events such as health events, such as mastitis, lameness, pneumonia, pregnancy diagnosis, and information on SERVs also feed into that database. And when the animal is culled, that information regarding carcass weight, fat, conformation score would feed in from the abattoirs for that individual animal. So all that data then can be used in our national genetic evaluations. So to give you an example of the account of records on the database, this is just a snapshot from our latest evaluation. So we run multi-breed evaluations, which means that data from all purebreds and all crossbreds, including dairy and beef animals, feed into the same evaluation. So this means, I suppose, that Angus can be compared to Hereford or Limousin for any trait of interest. So just highlighted here some traits that might be of interest. So for, I suppose, the beef cow survival evaluation, we've got nearly 9 million records feeding into that. For the carcass weight evaluation, over 11 million records. Genotypes, nearly 2.7 million genotypes, and weaning weight in and around 1.8 million weaning weights feeding into that evaluation. So just the second part of my presentation, I suppose, is on a general guide to how genetic indexes are derived. So firstly, I suppose, for the international audience, I suppose it's just important to get a brief understanding of what are the requirements. So the first thing is that a trait must show genetic variation. So what I have here is I have a person's hand. And if you think about that, and all the people that typically everyone has 5 fingers. So there's no variation within that trait. So you can't breed first. You don't know somebody that has 1 hand or 2 hands, or if you do, they weren't born that way. It wasn't due to their genetics. However, if we think of height of either an animal or a person, there's a lot of variation within that. So that means there's genetic variation, and we can either breed for tall or small cows, whatever it might be. So one figure that you'll often hear geneticists or people working in the breeding industry talk about is heritability. So what it is not necessarily very important. All you need to know is that once it's greater than 0, that you can essentially breed for that trait. The higher that figure is, the less records are required in the database to achieve high levels of accuracy. But once it's not 0, you can breed for that trait. The second thing is that the trait must be measurable and recorded routinely on a database that would be available for our genetic evaluations. And the final thing required, if we're to include a trait in a breeding goal, is that that trait must be economically or socially important to the relevant production system. So for example, in warmer climates, not Ireland, heat tolerance is of extreme importance, and many indexes would place a lot of emphasis within that. But in Ireland, we have more wet days and cold days than we have temperatures above 20 degrees. So it's not a trait that we would ever consider within the Irish breeding goal. So it's very important that the traits considered are relevant to the production systems that are in question. So how do genetic evaluations work? That's a question we're often asked, especially in the case of where an animal has never contributed directly to an evaluation itself. So say, for example, the carcass evaluation here. How we go about that is we have herds, so we've herds, 3 herds here, herds A, B, and C, where some animals have been slaughtered. That information would come into the ICBF database from the abattoirs, along with their pedigree relationship, which would have been recorded at birth, or again when the animal was genotyped. And then there is also a second source of information from herds who haven't either been slaughtered or their information doesn't feed into the ICBF database for any other reason, but their pedigree relationships was also recorded either at birth or when they were genotyped. And because we know that there are some animals, so these animals highlighted in red here are all half sibs across 5 different herds, we know, I suppose, that the animals that have been slaughtered would share similar properties, if you like, with the animals where we don't actually have their own slaughter information. So we do that, I suppose, down along the line. We trace different lines of ancestry And because we have information on a certain number of animals, we can then infer or predict for the animals where only their pedigree is known, so where only their sire or dam is known or the animal is genotyped. So that allows us to calculate a genetic merit for all animals. Now, a second concept, I suppose, is genomic selection or genomic evaluation. So that is, I suppose, as you know, Felicity was talking about, so where you take a sample of the animal, a sample of DNA from the animal, either through an ear tag sample or a hair tag sample, and that comes into the, the ICBF database. And what we do with it is, every animal, I suppose, has a unique code that is their DNA, and I suppose Ross will be bringing that up later. But essentially, what we have is we have a group of proven animals, okay? And those proven animals have been genotyped, so they have a unique code. And the typical term you'll hear us talk about is a SNP. And that's just basically where there are differences on the animal's genome. And so I've just taken the example of milk yield here as just for a simple example. So what we know for the animals that are genotyped, and that they also have their own progeny information, we know that animals that contain an A at this specific location, they produce 1 carton of milk. For the animals that have a G at that same location, they typically produce 4 cartons of milk. And for an animal that have a T at that specific site, again, they will produce 2 cartons of milk. So because we have the animals that have phenotype information and also SNP information, we identify associations between the 2 of those. And then for animals, so for young baby calves, where we just have the genotype information because they're either too young to give information, phenotype information themselves, or it doesn't come into the ICBF database for another reason, we can infer what their phenotype would be. So the animals with the G here, we suspect they would have something similar to the proven animals. So that would be 4 cartons of milk. Animals with the A would have the 1 carton, and animals with the T would have the 2 cartons of milk, because we're inferring from the older animals up here. So just a bit of context, I suppose, then. My final part of my presentation is to introduce you to some of the Irish beef genetic indexes. So firstly, what does the industry look like? So we have a 1.6 million strong dairy herd, of which almost 50% are bred to beef bulls annually. So you'll notice from the breakdown of beef sires here that I just brought up from last year, Angus would make up, I suppose, the majority of sires used on dairy females, of beef sires used on dairy females, excuse me, followed by the other traditional breed, Hereford. In the beef context, we've got 0.85 million cows, of which the continental breeds of Charolais and Limousin account for the majority of sire breed, followed by the Angus then. So within Ireland then, we have 4 breeding goals, all of which are profit-based breeding indexes designed for Ireland's agricultural sector to aid farmers in selecting more profitable and sustainable animals. So these indexes, they quantify the genetic component of the animal's performance across all traits of importance for Irish dairy and beef farmers. So this evening, I'm just going to focus in on the 3 relevant to beef bulls or beef farmers. So the first is the Dairy Beef Index, and this is used to breed surplus beef cattle from the dairy herd, which ultimately would be destined for slaughter. The second is the Replacement Index, and it's designed to breed cows for the suckler herd, whereas the Terminal Index here on the right is used to breed beef cattle from the suckler herd, which are destined solely for slaughter. So the latter 2 indexes, I suppose they're both specifically used on beef females, but they facilitate different farming systems. So some farmers may breed their own replacements, in which case the replacement index is most relevant, while other farmers may sell all their own suckler progeny as weanlings or take them through to slaughter, in which case the terminal index would be most relevant to them. So Irish breeding goals are constructed based on profitability. So that means that the traits which impact profitability the most tend to have the largest emphasis on the overall index. So economic values are derived by Teagasc, so that is the national research and advisory body in Ireland, who use bioeconomic models based on commercial systems to determine factors impacting profitability. So those estimates are updated routinely, and here you'll see an example of some of the costings. Now this example is a bit old, but I suppose these are updated very frequently, taking into account factors such as the cost of labour, cost of fertiliser, cost of ration, price at sale, gross margin, and different things like that. So within each of the indexes, we have different traits relevant to each production system. So in the past, I suppose within Ireland, focus would have been on improving terminal traits. So your slaughter and your carcass traits, which resulted in a deterioration of the maternal traits. So back in 2014, the replacement index was introduced in Ireland to improve, the maternal traits within the suckler herd, and also to maintain those terminal traits. So the replacement index, it's a monetary figure which is expressed as profit per calving of each daughter. So there's 17 traits within the index, and where I suppose what happens is the genetic merit for each trait, so that is what we would refer to as the PTA or EBV, as you would often hear it referred to probably, is multiplied by that monetary value, and then each trait is summed together to give an overall euro figure. So you might have a bull with a €100 figure, and that basically means that a bull with a figure of a €100 is expected to produce daughters that will on average leave €100 extra profit per calving over a relevant base animal. So different bulls can be compared against each other. So the cow traits within the replacement index, they would represent about 71% of the overall index. So what we're looking for is animals that have a decent amount of milk, who are relatively small in size but produce a good calf, are quiet, go back and calf, last a long time, and have a good cull cow weight. Then in terms of the carcass traits, because obviously we want that cow to produce good calves, the focus here will be on a little dystocia, good carcass weight, little feed intake, and good conformation and fat characteristics for slaughter. On the terminal side, basically what happens here is the cow traits are stripped out of the replacement index, and we're solely focusing in on the traits that would impact the progeny of that cow. So carcass weight makes up the overall part of the index, so about 40% of the index, followed by dystocia, feed intake, and carcass conformation and fat then would be the next big players within that index. Another index that we have is the dairy beef index. So that is, again, it's a profit-based breeding goal, and it's constructed based on a 50-50 split between traits that are important to dairy farmers and to beef farmers. So this index has only been introduced recently enough over the last 2 or 3 years. So it's where dairy farmers want to use a beef bull on their dairy females to increase the value of their surplus calves. But I suppose a big issue that we have on that side is that the dairy farmer needs to be sure that they have a bull that's relatively easy calving of short gestation. And on the other side, the beef farmer needs to make sure that the resulting animal will be of high carcass attributes, requiring little feed intake and things like that. So that is where the dairy beef index feeds in here, and you can see the traits included. So an example then of what it would actually look like if you were a farmer selecting bulls based on the dairy beef index or any other index, you would get the overall code of the animal, the details of the animal and the breed. You can filter, of course, by all of these. And you get the overall dairy beef index or replacement or terminal index. And you get a breakdown then of each of the individual components within that. So what exactly is published for an animal here in Ireland? So within the ICBF database, we have a facility, I suppose, where you can look up any animal. So if you place the tag number into a relevant section or AI code, the genetic merit information of each animal would pop up to you. So the first thing that you would see, I suppose, is our overall replacement terminal and dairy beef index. Their monetary values, as we spoke about, so higher euro values are more desirable. And then we have specific details down below then on the individual traits. So the first thing that is highlighted here, I suppose, is the index value, and we present that for the individual traits in terms of PTAs. Now, many of you, I suppose, from an international perspective, might be more familiar with the estimated breeding value, or EBV. They're very much the same thing in the sense that they're both measures of genetic merit, but because an animal can only transmit half of its own genetic merit, we present the PTA, so that is half the genetic merit of the animal itself. The other thing that is presented is the reliability. Internationally, you might be more familiar with the accuracy. Again, they're very similar indicators, basically, of how confident we are in the EBV, and that is all influenced by how much data there is on the animal itself in the evaluation or on the ancestral data of the animal. The final thing that you'll note here is we provide star ratings for each individual animal, both within breed and across breed for those animals. So it's basically just gives the farmers an idea of how that animal ranks relative to other animals within the breed or across all breeds. So where 5 stars is presented, the animal would be considered to be excellent for the trait, whereas where it's 1 star is presented, that animal would be considered to be very poor on that individual trait. So just to give you, I won't go through that just in the interest of time now, because I know I'm probably shoving on a bit, but we have, I suppose, we can provide these slides to Shane, and again, this is all recorded. And I suppose one thing that we do is we do validate all these indexes routinely. So all of our indexes have been validated actually, I suppose, in the last 2 years, most recently. And what we see consistently, I suppose, is that the animals that have that higher index value, so are more desirable, as we state on index, they do deliver better performance on the ground, resulting in higher profitability animals, whether it's replacement, terminal, or dairy beef index. So as you might touch on this, I suppose, a little bit later through the talks, but I suppose I've just shown you the indexes, I suppose, roughly as they stand today, but all our indexes are constantly under development. So we're always, I suppose, collaborating with different people, particularly, I suppose, with Teagasc in Ireland, and developing new traits. So, some of the traits that are of interest would be age at slaughter of the animal, methane measures, which Clodagh will cover later, as well as meat eating quality. We're looking at introducing, I suppose, a carbon subindex, and also at introducing additional health traits, I suppose, in the likes of TB, which is very relevant here in Ireland, pneumonia and calf vigor and things like that. So constant development constantly within the Irish system. So in summary, I suppose, look, ICBF provides independent genetic evaluations for the purpose of industry good. We have a huge quantity of data within the ICBF database, and I suppose this removes duplication across organizations, and it's very much a unique thing globally, and it's very much sought after internationally. We have 3 genetic indexes relevant to beef animals. So we have the dairy beef, replacement, and terminal index, all of which have been validated. And I suppose the final thing is that we're constantly doing new research and taking traits from implementation, from the research stage through to implementation, to provide routine genetic evaluations. So that's it from me now, Shane.